Today's news concerning the James Webb Space Telescope and its images are awe-inspiring and intimidating. This modern marvel has the technology to answer several of humanity's questions, including those about life elsewhere, with things like spectroscopy. Our list of 15 potential hosts for alien life is awe-inspiring and terrifying. From the popular sci-fi background of Exoplanet 6 to number 9's Water World, you'll want to stay tuned to the very end to see which far-off worlds make a good home. Also, make sure to like this video, subscribe to the channel, and hit the bell so you will keep up with all our releases. Do you have a favorite among these exoplanets? Or perhaps one we didn't cover? Leave a comment and let us know. Number 15. Wasp 96b. This new telescope will focus on 4 goals during its mission. These include understanding the formation and evolution of planetary systems, exoplanet formation, and studying the origins of life. Our search for an alien homeworld using the James Webb Space Telescope began in July 2022 when scientists turned its instrument package toward the planet Wasp 96b, a gas giant with a radius 1.2 times larger than Jupiter. First detected in 2014, the giant exoplanet has only about half the mass of Jupiter, making it a bit puffier than the 5th planet from our Sun. When the Webb telescope looked in on this alien world, located 1,150 light-years from Earth, it detected a signature of water, along with evidence of clouds and haze. Water is a critical ingredient for life as we know it, covering nearly 71% of our home planet's surface. While data indicates water here, it probably isn't very hospitable. The problem is that Wasp 96b orbits its Sun-like star close enough to raise temperatures over 1,000 degrees Fahrenheit. A single orbit takes only 3.4 days because this frightful planet is only 1/9 the distance between Mercury and the Sun. So while the sodium-rich atmosphere might contain water, its temperature far exceeds what we would consider life-sustaining. Perhaps we will have better luck finding more life-form-friendly targets as the James Webb Telescope looks elsewhere. Number 14. Europa. Some terror-stricken observers note that we might not even need to leave our solar system to find alien life. One of the more appealing targets isn't another planet. It's one of Jupiter's moons. At least 80 moons are orbiting this gas giant, but its 6th closest satellite, Europa, draws researchers' attention. It is the smallest of the 4 moons Galileo discovered in the early 1600s. Europa might be smaller than our moon, but it still ranks as the 6th largest in the solar system. Humans have always been intrigued by this moon composed of silicate rock and covered with a water-ice crust, gathering more evidence for potential alien life support as our technology improves. 2 future missions, NASA's Europa Clipper and the European Space Agency's Jupiter Icy Moons Explorer, have target launch windows this decade and hope to find signs of life. With an orbit of nearly 500 million miles from the Sun and a surface temperature that never exceeds -260 degrees Fahrenheit, you might wonder why astrobiologists are so excited. For starters, there is more liquid water under the frozen crust than on Earth. The crust shields the water from dangerous radiation from the Sun, and it has energy and organic chemicals. These are all considered the building blocks of life. The James Webb Space Telescope has already taken detailed near-infrared images of Jupiter's auroral emissions, cloud bands, and storms. It won't be long before its sensors look more closely at Europa's hidden oceans and volcanoes. Number 13. Enceladus. Our solar system's ringed gas giant, Saturn, also has a moon with the potential to host alien life forms. Enceladus is the 6th largest of Saturn's 83 moons, which are not within its ring system. This satellite is 790.1 million miles from Earth and is only 310 miles in diameter. Its surface of clean ice reflects nearly all of the sunlight that makes it to the Moon, and the top temperatures max out at about -324.4 degrees Fahrenheit. Those features do not seem supportive of alien life forms at first glance. Why should the James Webb Space Telescope examine the most reflective object in our solar system for signs of life? Just like neighboring Europa, the potential is what lies beneath the surface. Recent research from biologists suggests that life here is not only possible, it might already exist. It comes down to an abundance of the gas methane. Many astronomers believe this hydrocarbon could be one of the ways to detect life beyond our planet. And something is creating a lot of methane in Enceladus oceans beneath the ice-covered surface. Recent reports suggest production appears similar to means used by methanogenic microbes in Earth's oceans. You might not call it solid proof, but it doesn't hurt the chances that we already have neighbors orbiting our sun. When the Cassini spacecraft made flybys, it detected ice particles, hydrogen, salts, and organic molecules in plumes erupting from the cracks on the Moon's surface. The jettisoned material could show that it has an underground ocean with a similar makeup to ours, making a closer inspection with the James Webb Telescope a worthwhile observation. Number 12. LHS 1140b. Leaving the confines of our solar system once again, the James Webb Space Telescope will give us incredible glimpses at some potential life-supporting exoplanets. Directing the instrument package toward the constellation Cetus, for example, would bring LHS 1140 into view. The red dwarf is an M-type star with only 15% of the mass of our Sun, located approximately 41 light-years away. At least 2 rocky planets are orbiting the star, labeled LHS 1140b and C. There might even be a D in the neighborhood, but its existence is unconfirmed as of 2019. Astronomers know the planet LHS 1140b sits within the planetary system's habitable zone and transits the star's orbit every 24.7 days. That transit orbit places it in front of the star, along with the star's relative dimness, makes this planet a top target for the James Webb Space Telescope to perform atmospheric studies. The planet is 60% larger in diameter than the Earth and 7 times more massive. That places it in the super-Earth category, reserved for planets with a mass greater than Earth's but less than the gas giants in our solar system. Researchers using formulation models estimate the exoplanet could consist of 4% water, and water vapor detected in the atmosphere in 2020 confirms the presence of water. Number 11. Kepler 452b. Some scientists believe they have found Earth's twin nearly 1,800 light-years from our home world. This frightening discovery by the Kepler Space Telescope occurred in 2015 as the instrument examined the area around the constellation Cygnus. So why are astronomers calling this a possible Earth 2.0? Kepler 452b is around 1.5 times larger than Earth and 5 times the mass. That would make gravity twice as strong on its surface. The exoplanet orbits along the inner edge of the system's habitable zone, providing a temperature range friendly to water. This potential life-supporting satellite orbits its parent star at a similar distance as we orbit the Sun. Its 385-day orbit also parallels the Earth's closely. If that isn't enough to make Kepler 452b a distant cousin, then its parent star might. Kepler 452 is a G-type main sequence star similar to our Sun. It is 11% larger and 3.7% more massive, which might explain why it's 20% brighter than our parent star. Still, this Sun-like star and exoplanet represent one of the closest matches to our solar system that scientists have found. Having the James Webb Space Telescope take a closer look could help to determine if this super-Earth is a terrestrial planet or if it consists primarily of gas. Looking more closely at this older cousin might help scientists better understand Earth's ever-changing environment. Besides, its estimated age of 6 billion years gives it plenty of time to evolve alien life. Number 10. Tauseti E. Astronomers have used several methods to discover exoplanets throughout the galaxy. Satellites can be detected by transit as they pass between us and their parent star, creating a shadow that dims the light we see. Another detection method used by researchers is radial velocity. Here, data shows a change in the distance between the star observed and our location. Scientists know that planets cause their host star to wobble, changing the color of the incoming light. Radial velocity is what helped to detect our next candidate, and its short distance from Earth may tantalize or terrify you. If you look at the constellation Cetus, you'll find a star with your unaided eye called Tauseti. It is a G-type main sequence star with about 78% of the Sun's mass, and at under 12 light-years away, it is the closest solitary G-class star. Data from 2012, obtained from 3 Earth-bound telescopes, detected the wobble that indicated the star had companions. In 2017, scientists refined information on Tauseti E. This exoplanet is nearly 4 times more massive than Earth and orbits Tauseti every 168 days. The James Webb Space Telescope could increase our knowledge of this exoplanet by determining if it has an atmosphere. It might uncover clues about the mantle's chemical makeup, which some scientists believe played a significant role in life evolving on Earth. Most importantly, feedback from the James Webb Telescope might show if Tauseti E sits within the habitable zone or if it orbits too close to its parent star. Number 9. Gliesa 581G. The far-reaching sensors and state-of-the-art technology aboard the James Webb Space Telescope are perfect for finding new exoplanets or confirming the existence of controversial ones. Take, for example, the Gliesa 581 system located in Libra. The parent star is a red dwarf about a third of the size of our Sun, located 20 light-years from Earth. Astronomers believe it is one of the oldest and least active M dwarfs known, giving a lower level of solar activity that would be atmosphere-friendly to orbiting exoplanets. There are currently 3 confirmed planets and 2 unconfirmed planets orbiting this star. Could the James Webb Space Telescope help establish the existence of these unconfirmed exoplanets? Perhaps. That would justify the belief of those supporting Gliesa 581G, also called Zarmina. Since 2010, research have debated if Zarmina exists, with one survey debunking it and the next verifying its presence. The James Webb Telescope could solve this debate once and for all. If true, this satellite orbits in the 6th position around the parent star and the middle of its habitable zone. If the telescope can look closely enough at Gliesa 581G, it might determine if there is an atmosphere and what gases it contains. Zarmina might not make the top 10 targets for the James Webb Telescope to explore, but verification would go a long way toward raising its profile as a possible home for alien lifeforms. Number 8. HD 40307G. Another possible alien homeworld that stirs controversy orbits the orange K-type star HD 40307, located within the constellation Pictor. It is about 75% the size and mass of the Sun, making it a close match compared to other systems in our list. An apparent magnitude of 7.17 and a distance of 42 light-years doesn't make this star stand out, but the 6 known exoplanets might. Researchers confirmed 3 planets in 2008 and others in 2012. Of these, HD 40307G orbits the parent star within the habitable zone roughly every 200 days. It exceeds the size of the Earth, but is smaller than Neptune, putting it within the super-Earth category at over 7 Earth masses. The estimated orbiting distance is 0.6 AU, but that does not exclude the possibility of alien lifeforms. Scientists found this exoplanet through radial velocity, and some researchers have questioned its existence after updated Doppler spectroscopy in 2015. This is where the James Webb Space Telescope could play a role in ending the dispute. Along with validating the exoplanet, a closer look through Webb sensors might help identify the planet's characteristics and what gases might surround it in an atmosphere. With a long enough orbit, this super-Earth might have a climate and atmosphere needed to spawn life on its surface. Number 7. Gliesa 1214b. Pointing the James Webb Space Telescope at the Ophiuchus constellation would give scientists a better look at Gliesa 1214 and its exoplanet GJ 1214b. Nicknamed by scientists as Waterworld, this satellite is considered one of the likeliest candidates for having substantial surface oceans. It's large enough to be the second exoplanet in the super-Earth category. Its transit orbit across the smaller M4.5 red dwarf parent star provides an optimal profile for spectroscopic observations. In 2013, a Japanese team of planetary researchers determined the atmosphere here is water-dense, which might help to support alien life forms. Planetary models suggest it might be a more massive and hotter version of Jupiter's moon, Europa. Current observations estimate the exoplanet is 6 times more massive than Earth. It likely has an interior made from water ice surrounded by a thick atmosphere. That atmosphere, however, would make things difficult for life as we currently know it. Researchers believe the temperature range for the planet is an unbearable 248 to 539 degrees Fahrenheit. There are many unknowns about this exoplanet that the James Webb Space Telescope could still explain. Its sensors could help establish the volume of water on the planet, which some models estimate to be near 75% of its mass. A closer inspection of the atmosphere could also verify the existence of clouds and gas types in the atmosphere. Number 6. K2-18b. At 111 light-years from Earth, the next candidate for potential alien life was called the best candidate for habitability known as of 2019 by more than one astronomer. In the constellation Leo, you could view the red dwarf K2-18 with optical assistance. The star is ordinary for its type, but it does have 2 known exoplanets orbiting within its system. According to system tidal simulation models, K2-18c is likely a smaller gas giant that would be unfriendly to native life forms. On the other hand, K2-18b is getting lots of second looks from astronomers. Since its 2015 discovery, through transit detection, this exoplanet continues to show promise due to its location within the habitable zone and evidence of water. This planet has a mass of almost 9 Earths and a 33-day orbit around its parent star. 2 studies, including one using Hubble Space Telescope, surmised significant water vapor existed in the atmosphere. With the ability to look further than even Hubble, the James Webb Space Telescope could give a more detailed look at this awe-inspiring exoplanet. Researchers could use the spectroscopy instrument packages to determine what chemicals are floating in K2-19b's atmosphere, and might help to determine if it's a large terrain exoplanet or a mini Neptune. Number 5. LP890-9b. Some stars, like the red dwarf LP890-9, are cool planetary hosts. This star is 105 light-years from Earth, with 12% of its mass and 15% of the radius of our Sun. It also happens to be the second coolest star we've detected planets around. Located within the constellation Eridanus, it hosts 2 exoplanets. What is even more awe-inspiring is both appear to be super-Earths. The September 2022 announcement of planet LP890-9b brought attention to this likely terrestrial planet that is 30% larger than the Earth. Data from NASA's Transiting Exoplanet Survey satellite indicates this planet completes an orbit around its parent star in a shocking 2.7 days. Its orbit is 10 times shorter than Mercury's path around our Sun. That would be horrific for potential life on the planet, but the lower levels of stellar irradiation could still allow life forms to flourish. That makes it a possible candidate for future exploration by the James Webb Space Telescope. Detailed spectroscopy could verify if the planet sits within the inner edge of the system's habitable zone and the makeup of any detectable atmosphere. If an atmosphere is detected and contains water vapor, the possibility of alien life on LP890-9b improves tremendously. The form that life might take is up for debate as well. Number 4. Kepler 186f. Understandably, we would want to find an exoplanet similar to ours when searching for potential alien life elsewhere. That is why one of the satellites in the Kepler 186 system stood out to astronomers when first discovered in 2014. Located 582 light-years from Earth, this M1-type red dwarf sits in the constellation Cygnus in our night sky. It is slightly older than the Sun and has 5 known planets in its system. One of those, Kepler 186f, was the first Earth-sized exoplanet found in a star's habitable zone. The other 4 planets orbit too close to the parent star to be considered potential homes for alien life. Observational data from the transit method indicate the planet is slightly larger than Earth. Another consideration for exoplanets is the tilt of the axis. Recent studies from Georgia Tech reveal that Kepler 186f tilts with stability like Earth, meaning it might experience seasons like those found on our home world. Planets with severe tilt stability might make the climate inhospitable to life. Mars is a prime example of this, as its tilt is varied from 0 to 60 degrees. Many scientists feel Kepler 186f should rank highly on the James Webb Space Telescope list of exoplanets to explore further. Even if other signs of life support are lacking, data could help explain a lot about exoplanetary climates. Number 3. Kepler 62e. Intermediate-sized stars like the K-type main sequence Kepler 62 might also host exoplanets capable of supporting alien life forms. This relatively dim orange star sits in the constellation Lyra and is about 1,200 light-years from Earth. It has around 69% of the mass and 64% the size of our Sun. Estimates place it around 7 billion years old and a temperature of 5,778 Kelvin. There are 5 known exoplanets within its system, 2 of which are in the habitable zone. Kepler 62e is nearly 60% larger in diameter than Earth and makes a complete orbit within the habitable zone every 122 days. Since its 2013 discovery, the exoplanet has raised the hopes of researchers because of its life-sustaining potential. Many astronomers believe it could be a terrestrial or water-covered planet. Planetary models indicate that the exoplanet might have a warm and humid cloud cover from pole to pole. A water-covered planet might not support civilizations as we understand them here on Earth, but those with water might contain more advanced organisms. Several papers discussing the far-off world's formation and life-sustaining potential are available, but more research is needed. That is where the James Webb Telescope can step in. Its cutting-edge technology could answer many questions about Kepler 61e and its nearby companion, Kepler 61f. Number 2. Gliesa 1132b. Nestled in the constellation Vela is what some scientists say is one of the most crucial planetary discoveries beyond our solar system. It has been on astronomers' short list of exoplanets to study since being discovered in May 2015. Also known as GJ 1132b, this Earth-sized planet orbits the red dwarf Gliesa 1132 at a distance of 40 light-years from Earth. That relatively short distance makes a good candidate for atmospheric study using the James Webb Space Telescope package. What's intriguing to scientists is the planet appears to be regenerating an atmosphere that the parent star decimates with radiation. Researchers theorize the rocky planet is the remaining core of a once larger gaseous satellite. While most of the gas is long gone, scientists believe the Hubble telescope has detected a new atmosphere building around the planet that is 1.6 times more massive and 20% larger than Earth. Like other potential life-supporting planets orbiting M-type stars, it has a small orbit. GJ 1132b transits its parent star every 1.6 days at a distance of only 1 million miles. That horrific fact makes this planet hotter than Venus, and the radiation that continuously chips away at the thin atmosphere makes it less hospitable for life as we know it. Still, astronomers believe there is much to learn from this exoplanet that could help them pinpoint satellites with more ideal conditions. Number 1. TRAPPIST-1e. Finally, the James Webb Space Telescope has a future date with TRAPPIST-1 and its awe-inspiring number of Earth-like exoplanets. This M-type star is among the most common and oldest temperature stars in the universe and is host to a planetary system of 7 planets. The red dwarf star has a mass of roughly 9% of the Sun and is slightly larger than Jupiter. We discovered TRAPPIST-1 in 2001, and in 2016 and 2017, scientists found its extraordinary planets. Up to 4 of these exoplanets sit within the habitable zone, a range of orbits that planets can develop liquid water if atmospheric pressure allows it. The lucky contenders are TRAPPIST-1d, E, F, and G. Scientists believe these red dwarf companions formed similarly to Venus, meaning any water likely evaporated early in their formation. Researchers used terrestrial climate and photochemistry models to speculate that one of these exoplanets, TRAPPIST-1e, may have liquid water on its surface. If true, it could support Earth-type life forms in a system that is only 40.7 light-years away. That's close enough to say, howdy neighbor. With similar density, gravity, mass, stellar flux, and temperature to Earth, it ticks many of the boxes astrobiologists believe are necessary for life. Even the atmosphere is likely to be dense, like those found around planets in our solar system. TRAPPIST-1e is said to be one of the potentially most inhabitable exoplanets discovered, according to the Habitable Exoplanets catalog. As you can see, there are plenty of potentially terrifying homeworlds that the James Webb Space Telescope can explore. That exploration has already started. NASA released the first direct image of an exoplanet taken by the telescope on September 1, 2022. Judging by the 4-colored filtered frames of the gas giant HIP 65426b, we are about to get inundated with detailed data for years to come. The James Webb Telescope might even provide our first glimpse of an extraterrestrial civilization.